Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here are another two problems on variation. Variation problems are light, but it will help you develop your thinking skills slowly but surely in order for you to be prepared in engineering life. So I hope that you will enjoy watching and you can follow the explanations and solutions to these problems, thereby uh, molding you to become better analyzer, better uh, engineering students in the future. And I hope that you will succeed in your chosen career. So this is Engineers in Progress 9.42 on variations. This is the last problem or sets of problems in variations. Find x if 14 is the fourth proportional to 72, 42, and x. So that's the first problem. Let's focus to that problem first. So since 14 is the fourth proportional to 72, 42, and x, so 14 should be the last, then we write this into the form 72 over 42 equals x over 14. 72 over 42 equals x over 14. Since 14 over 42, 72 times 14 over 42. So 14 over 42 is 1/3, and 1/3 of 72 is 24. Therefore, x is 24. So we proceed to the second problem. Three transformers are rated 5 kilovolts amperes, 10 kilovolts amperes, and 25 kilovolts amperes respectively. The total cost of the transformers is 15,000 pesos. If the cost of each transformer is proportional to its kVA rating multiplied by the factor 1.0, zero point 0.8, and zero point 0.6 respectively, find the cost of the 10 kVA rating transformers. Then part C, the electrical resistance of a cable. Let's focus first on part B. So the total cost of three transformers rated as 5, 10, and 25 kVA kilovolts amperes respectively is 15,000 pesos. And it is mentioned here the cost of a specific transformer is equal to, or it is proportional to its kVA rating. So there is a constant of proportionality here. Then K times multiplied by this factor. So for the 5 kVA rating transformer, it is constant of proportionality. Then this factor, which is 1.0 times the kVA rating, which is 5. So for the 10 kVA rating, it is a constant of proportionality. This is the cost of the 5 kVA rating. This is the cost of the 10 kVA rating, which is a constant of proportionality. The factor, which is 0.8 as mentioned here. Then its kVA rating, which is 10. Then plus the cost of the 25 kilovolts amperes transformer, which is constant of proportionality, factor 0.6 times its kVA rating 25. So simplifying, this is 5K, 8K, so 13K plus 15K, so 28K equals 15,000 pesos. So 28K equals 15,000. K therefore is 3,750 pesos over 7 kVA. So pesos per kVA. Therefore, the cost of the 10 kilovolts amperes transformer is equal to this 8K. So 8 times 3,750 over 7. So we get 4,286 pesos if rounded off to a whole number. So that's it for this problem. Then 16C, the electrical resistance of a cable varies directly as its length and inversely as the square of its diameter. So if we write the equation, it is resistance R is equal to K times length divided by diameter square. So find the formula for the resistance of a cable if a 3,600 meter long cable 20 millimeters in diameter has a resistance of 0.15 ohm. So for the formula, as stated here, R is equal to constant of proportionality, varies directly as the length and inversely as the square of the diameter. So divided by d square. Then to solve for K, we have the resistance of 0.15 ohms for the 3,600 meter long cable, 20 mm in diameter. So 0.15 ohms equals K 3,600 over 20 square. And the unit of K therefore is, so simplifying 0.15 times 20 square over 3,600, that's 1 over 60 ohm mm square per meter. So the units are important so that when we solve a problem related to this or to this, we have another conditions there. Then the diameter should be in mm, the length of the cable should be in meters, and the resistance should be in ohms. So the formula therefore is K, which is 1 over 60 L over D square. So L over 60 D square. Problem 17. The value of C varies directly with X and the square of Y, and conversely with Z. When X is 2, Y is 1, and Z is 4. Z is 4, C is 100. Find the value of C when X is 3, Y 2, and Z is 5. So in this problem, we bypass the constant. It's not important. So we interpret this problem as C is equal to constant of proportionality. It varies directly with X and the square of Y. So X, Y square. And conversely with Z. So divided by Z. Solving for K, K therefore is CZ over XY square. And we equate that for the initial conditions. You just follow the symbols with subscripts. C sub 1 Z1 over X1 Y1 square. So C in the final condition, find the value of C when X is 3, Y is 2, Z is 5. Z is 5, then X is 3, Y is 2, so over 3, 2 square equals, in the initial condition, C is 100, Z is 4, X is 2, so 2, then Y is 1, so 1 square. Solving for C, C is equal to 480. Then finally, problem 17B, which is similar to 16C, the electrical resistance of a wire made of certain material varies as its length and inversely as the square of the diameter. If a wire 100 meters long and 1.25 mm diameter has a resistance of 30 ohms, find the length of the wire of the same material whose resistance and diameter are 25 ohms and 0.75 mm respectively. So R equals constant of proportionality, length over diameter square. So K is RD square over L. So final, then initial, equate to R1 D1 square over L1. So in the final, the resistance is 25 ohms, diameter 0.75, so 0.75 mm square over L in meters equals, in the initial, we have R 30 ohms, diameter 1.25 mm, so 1.25 mm square, the length is 100 meters. Solving for L, L is 30 meters. So that's it for this video. I hope that you were able to follow the explanation and solutions. This sets of problems are simple problems on variation.